So, dear local coordinators and remote center participants, I welcome you all in the third day of STC on machine learning using Python. And today we have invited Ms. Shruti Vadva. She is working with Hash Logic Infosec Private Limited as a director, and she is expert in the area of machine learning, programming languages like Python, R, including website designing, portals, and you can say primarily she is working in cybersecurity, having many years of experience working with several solutions with respect to this field. And I hope the session scheduled for today, that is particularly based upon how we can make use of logistic regression in order to predict heart attack and pneumonia detection using the SVM technique. So these are the two sessions which are scheduled for pre-lunch. So I hope the sessions are going to benefit you people. And with this, I request Shruti Vadva to please share her screen and start with the session.
Okay, ma'am. Thank you. Thank you very much, ma'am. Good morning, everyone.
Good morning, ma'am.
Shruti, approximately 20 centers are connected with us.
Okay, ma'am.
And plus 13 participants who have registered on ULX portal directly. So in total, we are having approximately 600 to 700 participants connected through different remote centers.
Okay.
So in case of any query, I have communicated to the local coordinators. So they can put before you the queries of the participants.
Sure, ma'am. Okay, let's start this session then. Very good morning to everyone. So we'll start the session. I'm sharing my slides. So we are going to start with the logistic regression now. As you have studied in the previous two lectures, now we are going with the machine learning algorithms. So there are many algorithms which we have to study. But for this lecture, so over here you can see there are classification techniques. We are having classification techniques also. We are having regression technique also. So when to apply classification and when to apply this regression, that we have to see. Okay, just quick tell me whether my screen is visible to everyone or is there any delay? You can type in the chat box.
Yes, Shruti, it's visible to the remote centers.
Okay, great. So now, as I told you that we are having classification techniques also, we are having regression techniques also. So now what we are going to do, we are going to do classification techniques. So because see this, classification techniques are an essential part of an machine learning algorithms. And we'll talk about the data mining applications also. And approximately 70% of the problems which we are doing in real time in data science are the classification problems. And there are a lot of classification problems that are available, but logistic regression, which we are going to do, is very common and is a very useful technique for solving the binary classification problem. So what is binary classification? We'll see everything. Don't worry about it. So we are having various categories of the classification problem in the logistic also. We have binary classification, we have multinomial classification. So we'll see everything basis on the data set also. And we'll do one case study also, into which we are having the data set of a patient of a heart. So we'll have to predict whether the person will have the heart attack, will suffer from or not. So that's kind of thing we are going to do as a case study using logistic regression. And there are other cases also where we can apply the logistic regression. So such as for if you want to detect whether it would be the spam or whether it will go to your inbox folder. So for example, even Gmail is adopting this algorithm, and the mails which are coming to it will check whether the mail will go to your spam folder or whether it will go to your inbox folder. How it will check? On the basis of the keywords like free, or if we'll say lottery. So these kinds of things will train our model, will train our machine. So on the basis of that, it will decide, okay, whether the mail which is coming, new mail which is coming, whether it will go to the inbox folder or whether it will go to your spam folder. So that's the kind of thing. And another, we can also predict the diabetes, whether a person is suffering from diabetes or not. So that's the thing. Even a customer, if we are having a customer that will purchase a particular product, or if there is any other competitor, so where we want to check whether the user will click on a given advertisement link or not. So that's a various examples which we are having on the logistic regression, that is the classification problem. And this logistic regression, we are starting with this algorithm because this is very simple and commonly used machine learning algorithm, and mainly it is used for the two class classification. Two class means binary, just like whether it will go to your spam folder or inbox. It's the two categories. Or whether is a person suffering from some disease like diabetes or heart attack. So true or false, that is a two class classification. So because in this problem we are having two classes, right? And it's very easy to implement also, and even we can be used as the baseline for any binary classification problem. So these are the basic fundamentals which we have to see, and we have to find out the logistic regression, the estimates, the relationship between one dependent binary variable and the independent binary variable. Now here comes a question that you'll see.
Shruti,
Yes, ma'am?
could you please increase the font size? It's request from the remote centers.
Okay, sure, ma'am. Is it fine, ma'am? Okay. So now for this session, we are having the agenda that first we will see what is the logistic regression, that is introduction to logistic regression. Yes, here comes the question that regression is the another technique, and we are saying the logistic regression is the classification. Then what is the difference between the linear regression and the logistic regression? So why we are calling it as a logistic regression? Why we are not calling it as a classification, right? It's a classification problem, but the name, as you can see, it's a logistic regression. So that you will see in another slide that we also cover, and then we'll see how this logistic regression work and how we can implement it with the help of the machine learning library. And for the machine learning library, we have the scikit-learn, and we can build the model using confusion matrix, and we'll see some advantage and disadvantage. So when you can use this logistic regression and when you can't use this logistic regression. So this is the agenda for today's session that we have to do. So now see over here, when data scientists may cross a new classification problem, so the first algorithm that may across come their mind is the logistic one. Now see, we are having two types of class problems, that is the supervised learning, and we are having the unsupervised learning. So I hope you are familiar with the supervised and the unsupervised learning. You can type in the chat box, are you familiar with the supervised?
Yes, madam.
Okay, great. Now see, and this category belongs to the supervised learning classification algorithm. And in this, we have to predict the observation to a discrete set of classes. Discrete means either 0 or 1, 2, like that. And practically it is used to classify observation into different category. That's why its output is discrete in nature. And sometimes we also call this algorithm is a logistic regression. And I told you it's a more simple, straightforward, and a versatile classification algorithms which we are using to solve classification problem, right? So even this is logistic regression is a statistical method when we have to predict the binary classes. So the outcome or the target variable that we have to see, there are only two possible cases for that. So for example, whether they can be used for the cancer detection problem, and how it do, it computes the probability. So it will find what is the probability of an event occur. So on the basis of that, it will use this, it will tell, it will predict whether a person is suffering from cancer or not. So why we are calling it as a logistic regression? Why we are using this regression word? Because this logistic regression is a special case of linear regression, because where the target variable is categorical in nature. So what does it mean categorical? Because it uses a log of odds as the dependent variable, and this logistic regression predicts what is the probability of occurrence of a binary event when we are using this logit function. Because over here, with the help of linear regression equation, we are using this logit function. So people who are new to the machine learning, they might get confused with the logistic regression, because they will think it's a regression algorithm, but it's not like that. Because logistic regression is the classification problem, and it's the supervised learning classification problem. And it is based because it uses the equation of the linear regression, and the linear regression is that y is equal to mx plus c, that is for the linear one. And if we'll say, if we are having the many values independent, if we'll say many values, if we are having, for example, x1, x2, x3 up to so on xn, so the line will be, the equation for that will be increases. So I'll just write the equation for you so that you can understand. Okay, my memory is full of my Gmail, that's why it's failed to create. Okay, let me open the pink pen. Yeah. So over here, as you see, when we are having one independent variable, y is equal to mx, we can write mx plus c, or we can write also, this is as the c, will write as the b naught. It's the notation which we can use, b naught plus then b1, and x is the over here. So this is for when you are having one independent variable. So this is the dependent variable y. Why it is calling as a dependent? Because it depends on the value of x. Because this will compute, we can get the value from the value of the x. So this is our independent. Sorry, this is the dependent one, because it depends on x, dependent variable. And if I'll talk about this, x is the independent variable. And this you can see b naught, b1, these are the constants which we can compute the value. So you have read in this linear regression. But if we talk about, because in the classification problem, we are having more than one independent variable. So at that time, the equation will become y equal to b naught plus b1 x1 plus b2 x2. So how many features or how many independent variables you are having, input you are having, that according we are going to take this equation up to so on bn xn.
Excuse me, ma'am.
Yes, sir.
Ma'am, these fonts are not clear. Can you make it?
Yes, sir. Sure, sir.
Okay. Thank you, madam.
Is it clear now, sir?
Thank you.
Okay, sir. So I have told that what we have done, that the for linear equation, that is we are having y equal to mx plus c, or we can write y equal to b naught plus b1x. So y is a dependent variable and these are x, these are independent variable. So why we are calling y as a dependent variable? Because output, that is y, it depends on the value of the x, right? And this is x, we are calling it as an independent variable, and because this does not depend on the value of the y. So these are the features and these are the constants that, yes ma'am. Okay, sure ma'am. For next time, I'll not use paint, I'll write in the word. Is it, if this is visible, this is fine, or should I write it again in the word? All right ma'am, all right. So now we have seen over here, right? So this is for and, because if we are having many variables which are independent, so we can write equation like this. So b naught plus, this is the one value, and b1x1, b2x2, and bnxn. So this is the equation which we are having. So now we'll see. Let me just go to my slides. It's over here. Yes. And I'll increase the font also. So see, this we have done. So as we have seen, the logistic regression is widely used as a statistical model and it is used for the classification purpose. And when we are having a given set of observations, so this logistic regression help us so that we can classify these observation in two or more discrete classes. So the target variable, the output, and target, we are calling it as the same. So that our target variable, or we can say dependent variable, or the output, it would be discrete in nature. That is 0 or 1, true or false, like that. And if we'll talk about the two or more discrete classes like 0, 1, 2, so we can take like that. And we can even you can use this iris data set over there when we are having the three classes of the flower. So now over there you are having three classes and you can easily apply the logistic regression over there. So this logistic algorithm works by implementing a linear equation. So we are having independent, or we can say explanatory variables. So explanatory and independent variable are the same. And that's what we are using so that we can predict a response value. So for example, if you have to consider the number of hours studies and what is the probability that student will pass the exam. So here, number of hours studies is the explanatory variable or the independent variable, and it will be donated by the x1. And probability of passing the exam is the response, or we can say target variable or the dependent variable. And in the next equation, we are going to denote it by the z. Over here, you can see. So this is if we are having one explanatory, that is if we are having one independent variable and one response or target variable. So over here, instead of z, y, I am writing z, but both are the same. So the linear equation, logistic regression works on mathematically, it's like this, that z equal to b naught plus b1 x. So it would be like this. But these are, see, b naught and b1, these are the coefficients, or we can say these are the parameters of the model. So if there are multiple explanatory variables, multiple independent variables, so that then this equation can be extended to z equal to b naught plus b1x, b2x2, up to so on bn xn. Again, these b naught, b1, b2, bn are the parameters of the model. So what we require that because we want the output, that the predicted response value is should be given by the equation, and over here we are denoting by the z, right? And now over here for getting this, we are applying sigmoid function. you can say logit function also, and over here the name we are using for it is the sigmoid function. So this predicted response value that we are saying Z, now we have to convert it into the probability value, because we have to predict the output, and we are saying that this logistic regression, it will tell the probability. Yes, so it will tell the probability whether the value whether the student will pass the exam or not, right? Or whether your mail will go into your spam folder or your inbox folder. So this Z is then converted, the output, that is probability we are getting value, the probability which we are getting, the value should be lie between 0 to 1. So we are using this sigmoid function so that we can predict this value to probability value. So this sigmoid function, it will map any real value into a probability value. It will tell you the probability, and that will lie between 0 and the 1. And in this machine learning problem, sigmoid function we are using so that we can map prediction into probabilities. And the graph which comes for the sigmoid function, it will be S-shaped. And if you see the graph of the linear regression, it is a straight line. I'll show you the graph also. So this sigmoid function has a S-shaped curve. That's why it is calling a sigmoid curve. And this sigmoid function is a special case of logistic function. And there is one mathematical formula for this also, for finding out what would be the probability for that. So the function, the formula for this is like this. As you can see, 1 divided by 1 plus e raised to the power minus z. So z or y, you can see it's the outcome. It's the value which we have just derived from the formula of the linear regression, right? So when you will get the value, what is the value of the y, you will apply this sigmoid function on the linear regression, right? So over here you can get the value, what is the probability you are having. So, and you can see the value lies over here. The graph would be like this, because the value should be from 0 to 1, and it would become like this, right? And let's first do, yes, linear regression versus logistic regression. So now the logistic regression, there are some properties of the logistic regression. What are the properties? That the dependent variable in the logistic regression, it follows Bernoulli's distribution. So if we'll talk about math, because it depends on the statistics. So this dependent variable, that is y, it follows Bernoulli's distribution, and the estimation is done through the maximum, because we are finding the maximum likelihood. How? That will see in the decision boundary. So over there we'll see that value. So now we have to see then when we are having we are using this linear regression, we are using the equation of the linear regression. Why we are using it? What's the actually use of the logistic regression? So see over here why the logistic regression is different from the linear regression. So as you can see, this linear regression gives you a continuous output, right? And but this logistic regression, it provides a constant output, or we can say discrete output. So linear regression we can use when we have to predict the house price or stock price, like the continuous value 2.1, 3.4 at that time when the value is the continuous one. So that's the example of the discrete output when we have to predict whether that's the continuous output when we have to predict the house price and the stock price. So then only we can apply linear regression. And when we have to apply this logistic regression, so when we want to predict the output, like whether a patient has a cancer or not, predicting whether customer will churn or not. So this linear regression is estimated. You can see we are estimating this using the ordinary least square formula. But this logistic regression is estimated through maximum likelihood estimation. So what is maximum likelihood estimation? This will also see in the next slide. And these are the differences where we have to apply and what is the base of the linear regression and the logistic regression, and for what when you're having the input of like continuous, or when you have to predict the output continuous, then we have to use the linear regression, and when you have to predict the discrete output, then we can use this logistic regression. right? And you can see the graph of the linear regression as well as the logistic regression also. So as you can see, there is a straight line between the linear, as you can see over here, x-axis and the y-axis. And for the logistic regression is a S-shape, because also we are using the sigmoid function, right? So that's why sigmoid function, the graph is like this, is in the form of the shape, and the values should be between 0 to 1. And there is one thing which I told you, that the ordinary least square method, and there is a maximum likelihood estimation. So now see over here, the likelihood maximization method, or we are saying this OLS, these are the distance minimization or approximation method. So when we are saying we have to maximize the likelihood function, it will find out the parameters that will produce the observed data. So if we'll see from the statistical point of view, this maximum likelihood estimation, it will set the mean and the variance as a parameter when we have to find out the specific parameter value for a given model. So that these kinds of parameter we can use so that we can predict which data we are required in the normal distribution. So that is the maximum likelihood. And if we'll talk about the ordinary least square estimate, these we are finding out by fitting a regression line. So we are finding a regression line, that is, which is the optimal or the best regression line on a given data points, that has minimum sum of the squared deviations, that is the least square error. So that is the method we are using. So both we can use to estimate the parameters. So this maximum likelihood estimation, it will just give us probability mass function. So that's why we are using the maximum likelihood estimation in logistic one, not the this least square method over here. Yes. So as we have seen the sigmoid function, and I have shown you the formula, and this sigmoid function you can also call it as a logistic function. And the graph already you have seen is a S-shaped curve. So that can take any real value number, and that we have to map into value between 0 and the 1. So if the curve goes to positive infinity, so y will predict it will predict the value become 1. All right, and if the curve which we are getting, it will go to the negative infinity, then the y will predict that the value it will become the 0. So if the output of the sigmoid function, that is if we'll talk about the mathematically, so if the output of the sigmoid function is more than 0.5, so that is the threshold value which we are taking it. So if the output of the sigmoid function is more than 0.5, then we can classify the outcome as a 1, or we can say yes. And if it is less than 0.5, so we can classify it as 0 or no. So the output cannot, for example, if the output is 0.5, so we can say in terms of probability as there is a 75% chance that the patient will suffer from cancer. All right, so that's how we are taking this value. So on the basis, first what we have done, we have applied the formula linear regression equation, and after that we have applied sigmoid function so that we can get the probability. And when we have get the probability, we have to change it into the value of 0 to 1. This is with the help of this. Right, and over here we are taking decision boundary. Decision boundary is the threshold value, and it's fixed over here, which we have the by default it's 0.5, and you can see if the value is equal to and greater to 0.5, then we can say it is belonging to the class 1 or true. And if it is less than 0.5, then we'll say it belongs to the class 0, or we can say it belongs, we can say the class 0 or the false one. Right, and now you can see over here that is the decision bound which we have calculated between how the 0 and the 1 value, and this is the sigmoid function. And now we have to marking the predictions also, right? So we have to see Now, when we know about the sigmoid function and the decision boundary in the logistic regression, so we can use our knowledge of sigmoid function and decision boundary to write a prediction function, because we have to predict it. So prediction function in logistic regression, it will returns the probability of the observation, whether being it's positive or negative, true or false, yes, like this. So we can call this as a class 1 and will denote by P class 1. And if the probability inches closer to 1 also, then we can also say we are more confident our model that the observation, it should belong to the class 1. So as we have seen, suppose the sigmoid function, it will return the probability of 0.4. So that means there are 40% chance of passing the exam. And if the decision boundary is 0.5, then we can say this, we can predict the observation is failed because the value is less than 0.5, which we have said it. Right? And there are many logistic regression assumptions also, which we have to see. So in this, we can see this logistic regression model, it requires the dependent variable either to the binary or the multinomial and the ordinal in nature. So what does it mean by, actually these are the types of the logistic regression. So first type is the binary logistic regression, and second is the multinomial, and the third is the ordinal. So binary, when we are having the two possible outcomes, such as whether a person is suffering from cancer or no cancer, spam or inbox. So that is the two. So binary is we are having the two possible outcomes. And in the multinomial, when we are having three or more nominal categories. For example, when we have to predict the type of wine, or you are having the flower iris data. So in that case, we are applying this multinomial logistic regression. And ordinal, we can say when we are having three or more ordinal categories. For example, if you have to give the restaurant or the product rating, so it will come to you, they'll ask you have to give the rating, and rating is either 5-star, or you can give number 1 to 5, or best, very best, excellent, like that, fair. So that kind of, so when you have to give the rating from 1 to 5, so at that time we can use this ordinal. So this requires, when we have to apply logistic regression, so it should belong to these three categories, and onto these three categories we can apply this. And it requires the observation to be independent of each other. So we are talking about it should be independent of each other, and observation should not come from the repeated measurements. We can't take that value. And this logistic regression, it requires little or no multi-collinearity among the independents, though no collinear. Now we'll see the collinearity also, that is if there are two or more independent variables are more correlated with each other or not, that we'll see. So if they are highly correlated with each other, because if two columns are or two features are highly correlated, then what is the use for taking both? Because we can use one, because both will give you the same value. So that means the independent variable should not be highly correlated with each other. So that what we assume, it will not be like that. And if you're having the data, so we have to remove the collinearity also. So logistic regression model assumes as linearity of independent variables and the log odds that we have to apply the linear regression formula. And the success is that logistic regression model also depend on the size of the sample, or we can say the data set. So if you're having a large data set, then you can achieve high accuracy, because this model will not work good on the small data set. So that's are the assumptions which we have taken for the logistic regression one. And we have already discussed as the types of the logistic regression, which I told you: binary logistic regression, multinomial, and the ordinal one. And in the binary, we are having the two possible categories: yes or no, good or bad, true or false, spam or no spam, pass or fail. So these are the categories. And in the multinomial, so when we are having three or more nominal categories, so when we are having the typical categories of fruit, so we have to categorize it. And ordinal, when we can use this, so when there is an intrinsic order that have involved with the categories, for example student performance, then we can categorize as a poor, average, good, excellent. So at that time you can take this. So these are the categories, these are the types of the logistic regression which we are having, right? And now let's come to the logistic one and we'll just quick review it. Yes. So now let's just quick review what we have done. As we have seen, this logistic regression is one of the most popular machine learning algorithms, and it comes under supervised learning technique. And it is used for predicting the categorical dependent variable when we are having a given set of independent variable. And this logistic regression, it will predict the output of a categorical dependent variable. Therefore, the outcome must be the categorical or the discrete. So over here, the discrete which we require, that is yes or no, then we can change it into the 0 or 1. So it gives the probabilities value which lie between the 0 and the 1. So this logistic regression is much similar to the linear regression, except how they are used, because linear regression is used for solving regression problems, and this logistic regression is used for solving the classification problem. And instead fitting a regression line, which we were done in the linear regression, we are fitting an S-shaped logistic function that will predict the two maximum values, 0 or the 1. And the curve that we got from the logistic function, it will indicate the likelihood of something, that is whether the person is suffering from cancer or not, like that. So this logistic regression is significant in machine learning algorithm because it has the ability to provide probabilities. So we are finding probabilities over here and classify new data using these discrete data sets, right? Continuous, or you can just do that. And this logistic regression we can also use to classify the observation using different types of data, and we can easily determine the most effective variables, what are the most effective features used for the classification. So that value we have got, and the graph which you have seen over here, let me show you once again. Yeah, with this, yes. Now, as you can see over here with this line, we are saying that 0.5, that is the threshold value over here. So at the midpoint where it is matching, it's the threshold value. And the below the value, which is the threshold, it will not accept it. And the value which is above it, above this line 0.5, we can say it's we can accept the value, that it will give the value 1. So below it, where the person is not suffering from cancer, above it the person is suffering from the cancer. So that would be likelihood. And this line comes from the decision boundary, as we can see it over here. So that is the basic which we have done, and we have seen the sigmoid function also, that it's a mathematical function, that we are using so that we can map the predicted values to the probabilities, and it can map any real value to another value that can be range of 0 to 1. So the value of logistic regression must be between 0 to 1. So it cannot be go beyond this limit. So the curve, it should be like the S shape. That's why it comes like that. And after this, we have used the concept of the threshold value, which defines the probability either 0 or 1. So over here, we can give the threshold value if tends to 1, and if it is above threshold, and if it is below threshold, then we can give the value 0. So that is what we have done, and there are few assumptions which we have done, we have already seen. And the equation also, we have seen how we can apply, and the types also. So now comes that we have to apply, we have to do the practical part of the linear logistic regression. And there is one library, that is if we want to build the model, and for that we have to use this scikit-learn, right? So if you want to predict any diabetes also, if you want to predict heart rate also, so the first thing which we need to do is that we have to first load the data set. So we have to first see what is the data set which we are having and what are the values which we are having into that. So let's see that first. Okay, let me see, is there any query? Okay.
Ma'am,
Yes.
small E represents what?
So see, if you are seeing the E value, so it is the constant, so it's the exponential, right? So it has a fixed value, so which you are having, and the logistic regression, that's the formula. So that is the exponential, and you have to get the Y value. So you will get just the log of that when you are solving it. I'll tell the value of E also in the sigmoid function, that is the constant, it's like 2.718. And it's E is the Euler's number, and that is the basis of the natural logarithms. So it's the constant value which we are having. Okay. By default, ma'am, it's the threshold value is 0.5. So see, because we are using the inbuilt algorithm, right? And we are using the this scikit-learn, and we can change. So you have to give the value if you will change the formula, and we can just pass the parameters. The threshold value you can also change on the that. Volume from my side, everyone can. Okay, the volume is fine. My voice is audible to everyone. Am I audible properly? Okay. Okay. So should we start with the practical part now? Okay. So let's move. All right. Sure. So now just tell me, everyone is using Anaconda or Google Colab, what you are using? All right. So if you want to start the practical with me, so okay, you are using Colab. All right. So for this, there are two things which you can use. There is one Anaconda Navigator, which I'll show you. As you can see on my screen, this is the Anaconda Navigator. All right. And this you can use it. This is a Jupyter notebook which you can use, and just you have to click on the launch button. So this I have installed into my system, and for any data science, for any if you want to work in machine learning algorithms, then you can install this Anaconda Navigator. This is a very good software. And the other thing is that if you're working on the Colab, so that's a open source and it's provided by the Google, it's developed by the Google. You can just move to Colab. I'll show you my Colab sheet also, but you have to write on the Google. So see over here, Colab. So when you write just Colab, because it's linked with your Gmail. And you can see these are my data set. These are my files which I have already worked on. And you can just open that one also. And if you want to write a new notebook, you can just click on the new notebook. So I'll show you. I have created this one. So it will show that one. Yes. So you can see it over here. So this is my Google Colab. And if you just want to click on the new, you can just write it. And if you want to work, it's almost similar like Anaconda. So see, if you want to add new line, you can just insert a code over here. And you can see this round button within this one. So you can just click for running it, for running the set. You can just click over this. So it will run. So there are few things which you have to see. So if you want to upload the file, so for uploading the file, either what you need to do, you can just import your file or upload your file into Google Drive, and then you can use it. Or the other thing is you can do over here is that you can just write this code, and it will give you the option that you can upload the file also. So over here you can see you can upload the file, and then you can just move it over here. So it will come it like this. So there are many options onto which you want to work. So just tell me, majority of you are working on Anaconda or Google Collapse, but I'll work on Anaconda for this because I can work on both, but my data is already updated on that. Let me go into this. All right. So everyone wants to just see, or everyone wants to get the wants to do the practical also. You can just type in the chat box. All right, let's start the practical then. Okay, so I have downloaded one data set from the Kaggle and it is easy available. I can send you the link also. So if you want to download, and now over here, you can see over this. So we are having this data set and the file name is hard.csv. So it's in the CSV format. And the parameters. So the first thing which you need to see is the parameters which we are having. So I'll just make it font large for you so that you can see properly. Yeah. Is it fine? Is it visible now? So see the first thing. Okay. So see the first thing, first we have to, when we have get the data set, so the things which we have to see, the features. So see the features over here, that is first the age. So over here we have to display what is the age of the individual, right? So you can see this is the age of the person, and the second column is says that what is the gender of the individual. So if it is 1, it is male, and if it is 0, it's female. So otherwise you can have the categorical data which we have already converted, that is the male or the female. So because your machine learning algorithms work on numerical data, so if you're applying these kinds of classification problem, you need to convert the categorical data, that is the string data, into categories, right? 0, 1. So you have to convert this. So there is function also which you need to do, and that you can also perform it. So see it over here. That we have already done, that 1 is given for the male and 0 is given for the female. And the next feature you can see over here is the chest pain type. So it will display the type of the chest pain that would be experienced by the individual using these formats 0, 1, 2, 3. You can see these are the categories which we are having. So 0 means typical angina, and 1 means atypical, and 2 means non-anginal pain, there is no pain, and third is asymptotic. So these are the chest pain we have taken, that 0 is the typical angina, and 1 is the atypical, and the 2 is the non-anginal pain, and the third is the asymptotic, right? And the fourth column you can see is the rest BPS, that is the resting blood pressure. It's the blood pressure. It will display the resting blood pressure values of an individual in these units which they are using. All right. And the next parameter call is the cholesterol. So it will display the cholesterol in a person. So you can see the value 233 to 50 like this. And FBS is the fasting blood sugar. So it will compare the fasting blood sugar value to the individual. So
can you provide us the data set?
Yes, sir, sure.
Okay.
I'll give you the link. Will you download, or I'll give you this one, sir?
Please provide the link of this one.
Sure, sir. Yes, sir. See over here, the same thing. It's the same. 14 columns.
Okay, ma'am.
I'll send you the link. So over here, this is the overview, and we can just go to the data. And this is the file, and for every explanation is also given to you. So you can see this. This is the explanation of the data set, and they have already given 1 for the male and 0 for the female. Everything which I was saying. So every explanation is also given. And what to predict, that we are going to try to predict whether it's between the 0 and the 1. So that is whether the patient has a heart disease or not. So that's what we are going to predict. And over here, this is the data. So you have to just download this with the help of this button. You just have to, I understand and agree. And there is one download button, this one, or you can just download all. So there is one sample file also. There is a clean data. So they have given. So you can just see. And there is a huge amount of data. So you can just download it. I'll give you the link, and it's the same one. Yes. So I'll give you just the link so that you can download. Done? Should we continue?
Yes, ma'am.
Okay. Oh, I was showing the data set. Right. This one. So now, next thing is that we have seen the fasting blood pressure. Yes. So over here, the value is 1 or 0 because the normal value for this is 120. And if the value of this fasting blood sugar is greater than 120, then we can say the true. And if it is not, then we can say else, that is a false one. And the next is the resting ECG. This is the resting ECG, and it displays the ECG, that is electrocardiographic results, and it is in the 0, 1 and the 2 form. And you will see the 2 also at down because they are having more rows. So you will see in the form of the 0, 1, 2. And resting ECG, if you are having 0, that you are having a normal, and 1 is that you are having a wave abnormality, and if you are having 2, then you are having particular hypertherapy. That is in the left part, and that is severe. And the next parameter, that is the maximum rate, heart rate achieved, and it displays the maximum heart rate that we are having, a rate achieved by the individual. So it will tell the maximum heart rate that is achieved by the individual. And EXNG, it displays exercise induced angina. So that is if they are having or not. So 1 means they are having, and 0 means no. And old peak we are having. So this is the ST depression that is induced by the exercise related to rest. So it displays the value which we are having in integer or float, as you can see. And the next is the slope. It's a 0, 1, 2, and it's a upsloping. 1 is flat, and 2 is the downsloping. And CA is the number of the major vessels. So it displays the value as integer or float, as we have seen. CA adds the 0 to 3. It's belong the value that the color of fluoroscopy. And thal we are having. So it displays thalassemia. That is, it's an inherited blood disorder that will cause our body that they have less hemoglobin than the normal one. So it displays that thalassemia. So 0 is for the normal, 1 is for the fixed defect, and 2 is for the reversible defect, right? And the last is the target or the output that we have to predict. And this is the diagnosis of the heart disease, which displays whether an individual is suffering from the heart disease or not. So 0 means no, they are not suffering, and 1 means heart disease is present. So that's what we are doing, that we are checking whether a person is suffering from it or not, right? So first, now we have seen that data set. There are many numerous columns also which we are having. So we have to see the tools also. We have to see the libraries which we have to apply. So now we are using this machine learning algorithm to predict the hard problems, and over here we are using this the libraries like pandas, numpy for data analysis and manipulation. Data visualization we are going to use with matplotlib and the seaborn. And for the logistic regression which we have to do, that is we are going to build with the scikit-learn library, and for building the models and the report. All right, so let's move to the Anaconda. So the first thing which you need to do is, this is your file and you want to upload this file into your home page of the Anaconda. So when you start with the Anaconda, you just have to click on this Jupyter notebook. All right, so when you just click on this Jupyter notebook, it will open this screen on your browser. Okay, so this screen will open, and there is one more thing which you need to do, because the data set which you require, so you also have to upload in the same folder, that is in the home folder of the Jupyter notebook. Or the other thing you can do, because we have to give the path, we have to
Excuse
tell.
me, ma'am.
Yes,
Uh,
yes sir, sure sir.
we are facing to download this data. The problem
Yes,
is
sir.
regarding to download this data, ma'am. Can you show us that how to download this data from Kaggle?
Sure sir, sure.
Can you show us? Because we have already logged in, we would not be able to download it.
Sure sir. Okay. Data sets no longer. All right. Yes, sir. This has been downloaded. I'll give the new link to you, and I'll show the data set again also. And as you have seen, the data set is downloaded with the name of hard.csv. And let me show this into this.
Ma'am, can you share this CSV file in the group of NIRRR, that WhatsApp group? Do you have the access?
No, sir, I'm not that into the group of NIRRR, but I can mail you.
Right, you can mail us.
Yes. Send me your email ID in the chat box. Send me, sir, your email ID.
Yes, ma'am, I'm just typing it.
Okay. It's hash. It shouldn't be the @.
It's Pooja, ma'am. Pooja
Okay.
IT@purnima.org.
All right. There is one also. Yes, that was asking. Done, sir. I have sent it to
Thank you, ma'am. Thank you.
mail. Sure, sir. Okay, let's continue this session. Yes, so there is one thing which I was saying it to you, the data set which we have just downloaded, you need to upload it over here on the home screen. Just click on the upload button, and over here there is one data set hard. Just click on it, click on open, and you have to upload it over here. So see, because I already have this data set into the same folder, that's why it is saying do you want to replace it, because I'm already having. So I'll just cancel it. So first step which you need to do, I told you have to upload your data set over here. And then we are going to create a new file, new Python 3. And let's give the name to it. Rename. And we'll rename it as STC Logistic Chart. Okay, rename it. So first of all, what we need to do, we need to import the libraries, all the tools which we require. So are you familiar with the EDA? Yes, tell me, are you familiar with the EDA? Okay. No issue. So EDA is like exploratory data analysis. All right, because first when you're having the data, so you have to observe the data, right? And you have to find out how many cases you are having for the false, for the true. So it's not like that we can, if you are having for the positive cases that the person is suffering from cancer, it's 1%, and rest your 90% data is, or 99% your data is like the person is not suffering from. So how you can able to model your machine, so how you'll able your model, how you can able to build your model on the basis of that, because every time will you give, because you have trained the model mostly majorly on the basis of the person is not suffering from the cancer or not suffering from the heart. So that's the thing which we need to do in the exploratory data analysis. In that we have to plot the libraries also, but don't worry, we are going to see. So first of all, we are going to upload the libraries, importing the main libraries which we require. So we'll just write import pandas as PD. So now see over here, pandas is the library. There are three libraries, NumPy, pandas and matplotlib. These are used for the data analysis. And the name which I have given for it, for the pandas, I am giving PD. So the nickname, as you are having your nickname which your parents call or your friends call you. So as like I am giving the PD as the alias name, so that I can't write pandas everywhere. I can just write its nickname. That would be feasible for me. And another library is that we have to import NumPy as NP. Okay, and then we are going to import matplotlib. Dot in this we are having pyplot as PRT. All right, and there is one more library for plotting it, that is a Seaborn, and we are giving it a name as SNS. Let's execute it. So for over here, if you're working in Anaconda, either you can click on the run button, and or there is one more thing, either you can click just let me wait for, yes. So when you'll see the star, that is it's in the processing, so you have to wait for that. And when you can see the one button that it's executed fine, so you don't need to have any issue for that. So if you have not installed this library, but if you're working on Anaconda, so these library already inbuilt into it. But if you want to install it also, if you want to check, then for this you have to write just exclamation and pip install NumPy or pandas or matplotlib, whatever the package you want to install. So that's how you need to do. And I'm just doing it comment for you because later I'll give this file to you, so you should know how you can install it. Or I'll just write installation. Yes, ma'am. GGG from Amshore. It's fine now. Okay. So let me make this line. I'll execute it. You will see that it will say it requirement already satisfied. Let's run this. And for running it, there is one also shortcut with the key. You have to just click Shift Enter. And now you can see, because I have this is already installed, requirement already satisfied. So that's what you see. Okay, so there are other packages also, because we have to implement the logistic regression. So, and it's in the sklearn library. So let's just import that also. So from sklearn, and it's the linear model. We have to import logistic regression. Just remember, for the logistic regression, L and R should be the capital one. Okay, so this we have done, and for this we are going to
Excuse me, can you scroll a screen little bit, because the step is
scroll up.
Yeah.
Okay.
Okay. Thank you. Thank you. That's it. That's it. That's it.
That's it.
Right.
Sure, sir. So logistic regression. So we'll just execute it. Shift Enter, and you can see it's done. And for this also we require some other parameters which we require. So let's import that also. That I'll explain when we are using it. So we'll just write from sklearn dot model selection. We have to import train test split. That I'll explain. And cross validity score also. Okay. And we'll see the confusion matrix also. We'll see the parameter, accuracy, everything from sklearn dot matrix. We'll import confusion matrix. And classification report. Okay, so now execute it. Done. So these are the libraries which we required it, and this was the first step. So now the second step is that we have to import the data set. Okay, so now what we will do, we'll import the data set. So we'll create a data frame now. So I'll give just the name df, and the data frame we can just do it's with the help of the pandas library. That's we are writing pandas, and into the pandas there is one method with the name of read underscore CSV, because this is a CSV file. So that is the function. That is the method which we are having in the pandas. If you want to access it, we have to write dot over here. And in the parameter, the parentheses, we have to write the name of the file which we want to access. and the name of the file is heart.csv. You have to write the extension also, otherwise it will give you the error. So let's just execute it, and it's done. So if I want to see whether it's done or not, there is one command df.head. Alright. By default, it will show you the top 5 values of your data frame. And if you want to see 3, 10, any value, for example, I want to see the 10 values. So let me just execute it. So now you can see my data set. These are my data sets, and the total values which it's showing, it's 0 to 9, that is the 10. So this was my data set, right? Should we proceed further? No doubt till here? Okay. All right. There is. Okay, I'll send to another. That is the, okay, this email. I'll send it to you. And send it. Done, sir. And now the font size is fine to everyone. Okay. Done. So now let's come to this part. Yes, so now see what we have to do. We have to do the analysis. So first we'll see how many rows and how many columns we are having in the data set. So for that, we are having one function that is with the shape. So what you need to do, you need to write your data frame name and just access the shape function. And see, it is showing that it is having 303 rows and it is having 14 columns, right? So this is the data set which we are seeing, and it shows how many rows and how many columns, and we have used the head function also. So now what you will do, because see over here, but this is an optional, that we want to just rename the columns. So over here, age, CP, it doesn't, I can't understand from this. So if you'll use the terminologies which we are having into that, which we have just studied from the data set, so that would be much easier for me. So first of all, I'll just do the rename of this column. So let me just do that. And it's the function with the rename. And over here, I have to write the column name. It's the column is the parameter, and because there are many, so I'll just write in the current braces. So now it is in the form of the age, small one, and it's the string, so I have to write in the this one. And over here, let me just write the capital one. By age, I want it like this. Is that? Let me write the gender. And for CP, let me write the chest pain. So we can do just like this. So for the next one, PRP, BPS. So for this, I'll just write resting blood pressure. And now for the goal, it should be cholesterol. For the FBS, let me write fasting blood sugar. And then press the ECG. I have to give in. Then let's write in ECG. Then for this, we can just write maximum heart rate. And then for EXNG, we can just write exercise and its angina. And we'll just left with few old peak. Let's give depression. And then for slope, and then for CAA, you can just write major. So over here we are having major vessels. And then for Kyle, just about to complete. All right, thalassemia types. And then last is the output. We can just
Excuse ma'am, is it
Yes.
mandatory? Is it mandatory for us to rename all the columns?
No. It's not mandatory. But for the significance, because I want that anyone can when see this data set or when see this file, so they just want to understand from seeing the column, but actually it's about. So that's why it's for the convenience. It's a good programming practices we are doing it. And we are saying in place. So if you will talk about in place, that in the same data set you have to make the changes. So that's why we are saying in place equal to true. That's it. Let's execute it. And it's done. So now we'll see again whether it's done or not with the help of the head function. Now I'll not give 10, it will take automatically 5 value. As you can see, and see it's changed also. So age, gender, chest pain, cholesterol, everything is changed. So now it's much better to understand what actually the values are about. Previously it was like a short name which they have given, which was not understandable. So that's why we have given like this. All right. So now the next step which we need to do is that we need to get the information about the data, that what actually is about. So for that we are having one info function or method in the pandas library. So see over here. This will tell, okay, this is a pandas core frame data frame. DF is the data frame, and it includes 303 entries, that is rows, and the index is from 0 to 302. And data columns, there are total 14 columns, and now you can even see whether there is a null value or not. And these are the column names. These are the total non-null values. So we are having total 303 entries, and these are the values 303. So that means there is no null value over here. So now, and what is the data type which they have used for each column? So that is the data type they have given. Data type, they can see you are using 1 is the float 1 and 13 are the integer 64. And the memory usage for this is 33.2 KB. So that kind of information is telling you by the info function. And there is one more function which will tell you about the data set, that is the statistics value. So if we'll just write df.describe, all right, and then we can just run it. And over here you can also see that is the count. So it is telling you that how many rows value, that is non-null values it is having, and what is the mean of the age column, what is the mean of the gender, what is the mean of this is the standard deviation. The minimum value, the minimum age which we are having into this is the 29, and the maximum age is this 77. So that is minimum value is 0 in gender and the maximum is 1. And 25% value is the age of the 47.5, and then we are having 50 is the 55, 75. So it is used for when statistics, when we have to plot the graph and when we want to understand that also. So this we can see from the count, mean, standard deviation, and what is the minimum value, what is the maximum value if someone asks. So we can just see with the help of this describe function, right? And now we have already seen there is no null value, but there is another function also. So if you want to apply the function to check whether there is a null value, NaN value. So for that we are having in the data frame is NA, this function, and what we need to do, we need to just sum it. So this is the function that how many NaN values you are having, you just need to add the value. So for each column, you can see there is no null values. As you can see, everything it is showing 0. So every column I want to say that according to the category, you have to add it. And there is nothing, that is the best thing which we have done. And the next thing which we have to do is the correlation. So I told you we want to take that columns which is not highly correlated, right? And now we'll just find the correlation matrix and we'll see what is the correlation between them. So for this, we are having the function for R and we'll execute it. And now over this, you can see the correlation. So now see, these are the rows and these are the columns. Okay. And age is for age and age, because they are the same. So that's why they're highly correlated. As you can see the value 1. So value 1 is the for that which is highly correlated. If you are having 0.9998, so that means it's very highly correlated, that from that you can take only one column. So if it is negative, that is not, they are not highly correlated. So you can see these values. So only from by seeing this value, you can predict that whether it's in correlated or not. So see the value, if it is 0.99 or something, then we can say it's high, but it's 0.09. So not. So there is no such value over here which is highly correlated, and the 1 value you will just get it for the same columns which you are having. Okay, is it fine? Is it clear till here? Yes, is it clear till here?
Yes, ma'am.
Okay. So it's 11:05. We can continue in the next session. So I'll explain this, then we can move to the SVM. And we can do one thing, because I want this should be clear, because practical should be everything clear to you. So what we'll do first this one, and we can apply SVM over this after the explanation. We can go that way also, right? So that practical part you can do more instead of the theoretical part, right?
Okay, ma'am.
Okay, so we'll meet at 11:30 then, and we'll continue from here.
Ma'am, can you share the code of this that you have done through Google?
I will share when we are done with this, na sir. Then I'll share the code.
Okay. Right.
After the second lecture at 1, I'll share this